7 says the figure below shows the first 3 revolutions of the spiral r equals 2 theta over pi measured in radians. Plot the graph on your grapher in the domain 0 to 6 pi. All right, let's do that first. So here's our grapher. Notice they say we're measured in radians, so let's switch this to radians. We'll go y equals, we'll clear out what's there, 2 theta divided by pi. And for our window, because we're in radians, and actually they tell us what to make our window here, plot the graph on your grapher in the domain from 0 to 6 pi. So theta is going to be from 0 to 6 pi. And I'm not real sure what to count by, so let's maybe say 0.2 or something like that. X min, again, not sure. Let's leave it like this. We can always adjust. But if we do graph it, this is what we get. 3 revolutions. And I can see I'm not quite large enough with this window. So let's change this window from negative 20 to positive 20 by 1s and negative 16 to positive 16 by 1s. Now here we have 1 revolution, 2 revolutions, 3 revolutions. All right, so plot the graph on your grapher in the domain from 0 to 6 pi. At what 3 positive values of r does the graph cross the polar x-axis? So your positive values of r are this way. Where does it cross the polar axis? This point, and this point, essentially. Well, we can see that every time we wrap this around, every time we wrap this around is where it crosses. So that's one complete revolution. Well, one complete revolution is 360 degrees, but when we're in radians, one complete revolution is 2 pi. That means our angle of rotation, which actually is what theta represents here, our angle of rotation in radians is 2 pi. So your r value is going to be 2 times theta, complete revolution, over pi. So 2 theta, that's our revolution, over pi. Or 4 pi over pi, and you see a nice cancellation here. Or basically when r is 4, you would have wrapped all the way around. Now, if I trace it, okay, you notice you're tracing theta, you're not tracing r. So I'm going to trace 2 pi, and notice r is indeed 4. So every time we wrap it around, we're going to get another positive r. So the next revolution is 2 pi beyond what we already did, or 4 pi. So 4 pi gives us r is 8, and then 2 more pi. Didn't like that because my window wasn't big enough here. I have to rotate a little farther past this to be able to trace this to 6 pi, but we see that is indeed r is 12 when it hits there. So at what 3 positive values of r does the graph cross the axis? R is 4, r is 8, and r is 12. And basically has to do with our angles of rotation. Rotate it all the way around. We get our first one, rotate it around 2 times. We get our second one, 2 times 4 is 8. rotate it around 3 times, or 6 pi. Two times 6 is 12. All right, now the next question says extend the domain to negative 6 pi to 6 pi and describe what you see. So if we change our domain from negative 6 pi to positive 6 pi, describe what you see. I first want to show you what we saw when we didn't have it that way. So here's what we saw. We saw this thing spiral out 3 times. Now, when I change my window to negative 6 pi to positive 6 pi, what do we see? Well, first we see it spiral in 3 times, and then we see what we saw before, where it spirals out 3 times. Okay, so describe what you see on your graph, or I would say we see it spiral in and then we see it spiral out. Right? God's blessings to you. Have a good day.